Example problem 9 is part 2 in the 3-step problem that is between example problems 8, 9, and 10. So the problem reads, underwater, the amplitude of the pressure in a sound wave is 500 pascals. So pressure and the Z value is the same from part 1 of this problem. In part 1 of the problem, we calculated the intensity to be approximately 8.68 times 10 to the minus 2 watts meters minus 2. What is the intensity of the sound in units of decibels? So that dB is called decibels. So we're not looking for regular I like we did previously in this unit. We are looking for sound intensity in units of decibels. And there is a new formula for that. It is 10 log intensity in units of watts meters minus 2, like that we previously calculated, divided by 1 times 10 to the minus 12 watts meters minus 2. So that's what you're going to use to calculate sound intensity, not just regular I by itself. So we have everything here that we need, and this 1 times 10 to the minus 12 in this equation is always going to be 1 times 10 to the minus 12 on the denominator. It will never change. So 10 log, and so you need a scientific calculator for this because you do need the log button for part 2 and part 3 of this equation. The intensity that we calculated previously is listed in the problem here for us. So 8.68 times 10 to the minus 2 watts meters minus 2 divided by 1 times 10 to the minus 12 watts meters minus 2. And so the easiest way to put this into your calculator is going to be type in the number 10, then hit the log button. So 10 log, a parentheses is going to open automatically for you. And so you would write 8.68 second E minus 2 divided by 1E minus 12, close parentheses. That's going to be the easiest way to put that in there. And so whenever you do all of that, if you're in scientific mode, you will get 1.0938 times 10 to the second decibels, or if you're in regular mode, you'll just get about 109 decibels. Let me know if you have any question with example problem 9.